Okay, so in this video, what I want to take a look at is being able to read to and read from and write to binary files in Java. So the breakdown for this is going to be that I first want to talk a little bit about conceptually how we are storing data in a binary file, the distinction or how that's related to the prior approaches that we've taken with text files, and then also expand on this with an actual implementation of this in Java. So up to this point, we've been working with text files. Anytime that we want to be able to manage data in our program, we want to write that to a file. We've written it to these files that have this .txt extension. And instead now what I want to go ahead and do in this program is be able to write to a binary file. So this is going to be something that uses the, in this case, we'll be using the .dat extension. So you can think of it as like a data file. And we want to be able to see the representation of data inside of that file. So to start off with, we'll use a simple example here. So let's say that we take some number. So let's do like 1297. And we want to go ahead and describe how this would be stored in a text file and a binary file. So let's imagine that we've got this 1297. We've stored this into some variable in our Java program, and we now want to take that variable and write its contents. So this number that we have right here, we're going to go ahead and write that to a file. So in the case of a text file, the way that we can think of this is that we have this breakdown of essentially 4 spaces for each one of the 4 digits, and each one of those 4 digits will be stored as its own individual character inside of this text file. So when we do this, we'll have the digit 1 as a character in this first position inside of this file, and then have 2 going into the next position, and then have 9 the third position, and then 7 at this 4th position. So in this particular case, what we've done is we've taken this number 1297. If we imagine that this is an int, then inside of our Java program, this is going to be taking up 4 bytes of space, so 4 bytes of memory. But when we put it into the text file, if we want to break up each one of these individual characters, each one of the digits as its own single character, in Java and in most languages, we generally describe characters as being 2 bytes each. So in this case, we've taken this 1297 that was 4 bytes for an integer, and we've now converted that to an 8-byte sequence of characters. So in this case, we've actually had to increase the amount of space that it takes to store this into our text file. And this is only dealing with a 4-digit number. If we continue to add more digits to this, all the way up to, say, the maximum possible value for an integer, then the amount of space this will take up in our text file will continue to increase over time. Whereas if we deal with a binary file, then what we can go ahead and do is just take the binary representation of this number, and we can store that into the file instead. And in this way, no matter what the size of our number happens to be, no matter how many digits are in that number, it's always going to be 4 bytes as long as it retains that int data type. And so when we store this into our binary file, that will also continue to retain those 4 bytes. So if we do that here, what we're going to do is essentially have the same space. And right here, what I'm going to go ahead and do is break this up into the 4 individual bytes. So in a sense, these are kind of sort of equivalent. We have 4 digits, 4 bytes. Obviously, for our characters, each one of these was 2 bytes. But a nice little one-to-one comparison. So for this one, what we're going to go ahead and do is just describe each one of the 4 bytes for this number. See if some of these will fit. I'm just going to place them right here so we can see them. So the first byte is going to, or the first couple of bytes are this. Since this number is not very large in the scheme of ints, these first 2 will be zeros, and then the next couple of them we'll start to add in the rest of this. And so when we actually end up storing this as binary, what we end up with is this sequence of zeros and ones. Typically, if you actually have some kind of editor that allows you to open a binary file and be able to see the data without it being completely scrambled, generally speaking, you're going to see these as hex digits. So When we talk about this in terms of hexadecimal, just a very brief breakdown of this, each one of these 4 bits that we see, that's going to represent a single hex digit. So say, for example, with this, these first 4 zeros and the second 4 zeros, that makes up 0, 0. So when I open this later and show you this, these first 2 will be 2 zeros and 2 zeros. The next one, we've got 4 zeros right here. This will make another 0 in hex. And then 0, 1, 0, 1. This is going to make the number 5. Go ahead and place that here. And then for this last one, we've got 3 zeros and a 1 for each one of these. So the first one is going to be a 1 in hex, and then the second one's going to be a 1 in hex. And this is a very quick, simple breakdown of it without even bothering to explain how I'm converting from binary to hex. So you'll just have to trust me on this one. But essentially, if we look at this inside of a binary file, it's going to be written in this format. So when in a moment, I'll go ahead and use this as an example. I'm going to write this data to a binary file, and we can actually see the sequence inside of it. Okay. So we'll go ahead and come over here. We're going to go ahead and create a new program or a new project for this particular one, since we're going to be talking about binary files. I'm just going to go ahead and call this, go to my Java projects, I'll go ahead and call this my binary file demo. Okay. So for this binary file demo, what I want to go ahead and do first, we'll just go ahead and create a very simple case where we just write just a little piece of data, in this case this 1297, to a binary file. And then I want to expand on this a little bit so that we can actually do a little bit of either reading or writing with that binary file. So we'll have our public class. In this case, this is going to be our binary file demo. We'll have our main method, so public static void main. Our string array of arguments. And then inside of here, what I'm going to need to do is include a couple of the different classes that are related to being able to manage binary files. So these are actually going to be more things that come from our I/O package. So in addition to being able to use classes that are related to writing to or reading from a text file, this package also includes the classes necessary for doing this with binary files. So to start off with, for this particular one, the first thing I'm going to need is going to be my int for my number. So this will be 1297. I can go ahead and get that one out of the way right now, since that's one of the simpler parts of this program. The next thing we're going to need, we have 2 classes in particular that I'm going to need to include for this. So the first one is going to be the file output stream. So I'm going to create a class that allows me to essentially produce what we refer to as an output stream for files. This output stream basically is going to take my data in the form of the sequence of bits or bytes, since we need to be able to write to a binary file using that this series of bytes rather than interpreting it as characters. So I'm going to use a file output stream. So a pretty simple name that I can give this is just going to be fstream. Okay. So then we'll go ahead and say this is equal to a new file output stream. And then we can go ahead and specify the name of a file that we want to write this to. So for this particular one, I'm going to go ahead and just call this binary. Okay, there we go. And for the extension, we want to do this for a data file, so it's going to be .dat. Okay. The next thing I'm going to need is to then specify the data that I want to write to this file. So then we need a data output stream that's going to set up our be set up with our file output stream. So for this one, we'll say output file. This will be equal to a new data output stream. And for this one, we're going to pass in our fstream. Okay. So then what we can go ahead and do is take our output file, so this data output stream. So I say output file dot, and this is the part where we're going to call one of the methods to be able to write to this file. So in this case, because I'm going to be writing this integer to it, the method I'm going to use is going to be writeInt. Okay. So you can kind of think of this very similarly to the scanner methods, where we would use the word next, and then we'd use some kind of indication of the type of data that we're trying to scan or trying to get from the user's input, or maybe from the input of a file. In this particular case, we're going to be using write and then some name that's associated with the type of data that we're working with. So when we're dealing with integers, the method we want to use is write int. And then right here, what I'm going to go ahead and put in is just this number. Okay. And then finally, once I'm done with this, I want to go ahead and make sure that I actually close this. So just like when we were working with our text files, again, we still have to make sure that we close the that stream when we're done with it. So we're going to be doing this with our data output stream. We want to go ahead and close that. So go ahead and include that at the very end. And then also one other thing I'm going to go ahead and include for right now is going to be a throws clause. But in a moment, when we start to expand on this, I'm going to go ahead and modify this so that instead of using this throws clause, we'll switch to try catch blocks. But for right now, we'll go ahead and keep this kind of simple. So we're going to do throws IO exception because, again, this is still working with file IO. So this is still going to be the same set of exceptions that we were expecting. Okay. So then we can go ahead and come over here. We'll go ahead and compile and run this. So we'll say Javik. We want to grab binary file demo. Go ahead and run that. And so we run it. We don't see any errors or exceptions being thrown. So that tells us that it was able to successfully execute the program. So I'll come over here and we can now look through this and we can see our data file right here. So one of the things to note that you might have caught already is that when we're working with these two classes, this file output stream and data output stream, it functions very similarly to when we were using the printWriter class, in the sense that if the file doesn't already exist, I didn't have this file created initially, it'll go ahead and just make that file for me and then start writing data to it. So we can go ahead and come over here. I'm going to go ahead and open this file, and the expectation when I open this is that it's going to be this sequence of characters, or the sequence of hex digits that we see right here. Go ahead and open that up, and we can actually see that right here. So we've got our first 00 for the first byte. We've got our second 00 right here for this next byte. We then have the 05 right here for my third byte. And then we've got the 11 right on the end for the fourth byte. Okay, so this is going to be the value 1297, 1297 in binary. And so, of course, whenever you start writing a lot of data to this binary file, you're going to see a very large sequence of characters, kind of like this. Because this is in hexadecimal, eventually you'll also see other characters like A through F. In most cases, if you see this very large sequence of hexadecimal characters like this, it pretty much looks like gibberish to you. So typically, what you want to be able to do is to, once you've actually written to that file, you want to be able to extract that data from it so you can read from it. So in order to do that, we can go ahead and include another pair. So if we have file output stream and data output stream to be able to write to the file, we can also go ahead and include a file input stream and a data input stream to be able to read from the file. And for this particular case, what I want to go ahead and do is show a different way that we can set up these two classes. And so what I'm going to go ahead and do is just write my data output stream, and then I'm just going to go ahead and put in, instead of like say some kind of variable, I'm just going to put in my new file input stream object. So the way that I'm going to do this, we're going to have our data input stream. This is going to be for our input file. This is going to be equal to a new data input stream. And inside of here, I'm going to put in a new file input stream. And then inside of the constructor for my file input stream, I'm going to put in the name of the file that I'm trying to read from, which is going to be this binary.dat file. Okay, so I'll go ahead and save that. The next thing I want to go ahead and do is include a method to be able to actually read that integer. So we're going to have our input file, and the method I need here, so we used writeInt to be able to write some value to it. Now we're going to use readInt to be able to read some value from it. And in this particular case, I'm not going to need to pass in anything to this because of the fact that in this case, I needed to pass in the thing that I wanted to write to the file. But for this one, when I say readInt, it's just going to go ahead and just check for wherever it's currently located in the file, the very next thing that it's going to be looking at would need to be an int, and it's going to try to read that from the file. In this particular case, the only thing that we've written to this file so far is just this one singular int, so that's all I needed to be able to read. And then what I can go ahead and do is just take this value, and we'll just go ahead and print this to the console. So we'll take everything we have right here, and then we'll go ahead and make up a little print statement. So system.out.println, and then we'll just go ahead and put this inside of the println method. And then again, last thing we want to go ahead and do is make sure that we actually close this file. So this was our input file. We want to go ahead and close that as well when we're done with it. Okay, so now if I go ahead and compile and run this, the first half is just going to essentially be trying to write to the file again. Another thing to note at this point is that when I'm using the file output stream, just as it is right now, this is going to overwrite anything that's inside of it. In a moment, I'll talk a little bit about the distinction between overwriting and appending when it comes to binary files. But for now, basically what's going to happen is it's going to erase this data and then just rewrite the exact same thing to it. So we're not going to worry too much about that. It's not really going to have any bizarre effects on this particular program. It'll basically still run exactly the same way as it did before. The one difference is that now we're going to take that value and print that back out to the console. So we'll come over here, go ahead and compile this. Go ahead and run it, and now at the very end of it, we can go ahead and print the value that we put into the file back out to the console. In this case, it's going to be printed back out as the actual int value that it was. So in this case, it's going to go back from binary to being in this decimal format that we actually understand. Okay. So now the next thing I want to go ahead and do, there are going to be two major things that I want to change about this. The first is that I want to modify this so that instead of just giving it a value to write to or read from the file, I want to allow the user to be able to just go ahead and specify any text that they want. So we're going to need to modify this a little bit to allow user input. We're also going to have to modify our write and read methods to, instead of taking integers, we're going to allow it to take essentially any kind of string of text. So we need some equivalent. Basically something that is equivalent to the next line method of the scanner class, the method that we use to read a string of user input. We need something that is equivalent to that for binary files. And the other thing I want to go ahead and do is get rid of this throws clause so that I can go ahead and build this in a way that uses try-catch blocks to make it a bit more robust than just relying on our this exception handler from Java itself. So the first thing I'm going to need to go ahead and do, in addition to this wildcard import for all of the IO classes, we'll also go ahead and bring in the scanner class. We'll go ahead and save that. Coming over here, we're going to get rid of this int for number, and instead we'll replace this with a string for input from the user. We'll initialize this to just an empty string. In addition to these, one other method that I'm going to need is going to be the scanner class. So we'll have a scanner for the keyboard. This will be equal to a new scanner. And this will be for system.in. Okay. So we'll be using this to read from our standard input stream. Then we can go ahead and include our request to the user to specify some content that they want to write to the file. In this particular case, I'm not going to ask them for the name of the file as well. Instead, we'll stick with just writing everything to this binary.dat file. If you'd like to, you can go ahead and modify this a little bit further to also allow the user to specify the name of a file. That way then there's even more flexibility with it. But in this case, we're just going to set it to just this file. So we'll have a print statement here, and all this is going to ask for is just some content that they want to write to that file. So we'll just say, please enter, let's see, content to write to file. And then what we can go ahead and do is just take their input, so that variable, say this is equal to the next line. So we'll just go ahead and grab that string of input that they provide us, and we'll store that into our input variable. And then the next thing I want to go ahead and do right here, this is where I'm going to go ahead and start setting up my try blocks, my try-catch blocks. And specifically the way that I want to do this, because we're working with files, so we have our file output stream and our data output stream, and we know that when we're done with them, we want to go ahead and close them. This is a very useful hint to us that these are going to be using the closable class. And the thing that I had mentioned before when we were working with text files is that we can actually use those try with resources blocks with things that use that can be closed, so things that implement the closable class. So I'm going to go ahead and do that right here. So I'm going to say try, and the way I'm going to do it is very similar to this line that I have right here. So we want to do something kind of like this, but we're going to now do it for both of them. So we're going to have our data output stream. Let's call this output file. This will be equal to a new data output stream. And inside of here, we're going to have our file output stream. So say new file output stream. And then inside of this file output stream, we're going to put in the name of the file that we're trying to write to. So this is going to be binary.dat. Go ahead and at least get the body for this started. And one other thing I'm going to come up here and do is set up my word wrap. So we can go ahead and have that wrap to the next line. That is still not great. So what I'm going to do is move this portion right here to the next line. So we'll just go ahead and have our entire try block right here. So just kind of keep in mind this little formatting that I'm doing with it. And then the next thing we can go ahead and do, so we can go ahead and remove both of these lines, since we're just going to do that right here. And we'll go ahead and take our output file, .write int. We'll go ahead and remove that. And we'll move that up here. And instead now, there are going to be two things I need to modify. The first is that I'm no longer writing a number to it. Instead, I'm using this input. So we're going to go ahead and remove that and replace it. The other thing I need to go ahead and do is change this from write int to a method for strings. So the equivalent method with binary files when it comes to reading or writing a string is going to be, in the case of writing, is going to be write UTF. Okay. And then the next thing I need is my catch. So we'll be able to catch any IO exception right here. And let's just go ahead and have it print out the default message for the time being. So if anything goes wrong, it'll just go ahead and tell us precisely which kind of exception was thrown. And we can just kind of take a look at that if anything goes wrong with this. We then go ahead and remove our close. Since we don't need this anymore, our try with resources is just going to automatically close this for us. The next thing we'll go ahead and do is set up the same try with resources that we have right here, but for our input stream. So we're going to say try, open up these parentheses. We're just going to take this line right here, just go ahead and grab all of that and move that into here. We'll also go ahead and move this, use that same formatting. We'll have our body, and then from our body, what we want to go ahead and do is just be able to print out that line that we're reading from the file. So just do that right there. We'll then include a catch. And we're going to say IO exception. So we'll do an IO exception E, same as what we did for our outputs. And in this one, we'll go ahead and just print out the same thing. Basically, if we have any errors, we just want to be able to catch their default message. Just take a look at what's going on there. And once we've got all this set up, we no longer have any reason to keep this throws clause in our method header. So we'll go ahead and remove that. Go ahead and save this. And then we'll go ahead and compile and run this. And now the expectation is that we can just go ahead and write any kind of data that we want to this file. So it'll just be in the form of a string. And then we can go ahead and we'll go ahead and write that to the file, and then we'll read that from the file. So if we want to read that from the file, one other thing almost forgot about was that we need to modify our read as well. So we want to go ahead and make sure that we're doing read UTF right here. So we'll go ahead and save that. We'll go ahead and compile this and run it, and then we might expand on a couple of additional things as we go. So let's go ahead and clear what we have right now. Go ahead and compile this. Okay, so we'll go ahead and write something to it. So we'll run it. So we'll enter some content to write to this file. So again, I'm just going to go with the same sort of convention that I've been using, which is just use the phrase hello world. So just go ahead and write this out to the file, run it. So we managed to go through the entire thing. There are no exceptions being thrown, so it just prints out the phrase hello world back to us. And then, of course, the part that we're most interested in, we can come over to our binary file, and if we open this up, now we can see this sequence of hexadecimal digits, so a whole bunch of data, and this is going to be the entire phrase for hello world written in hexadecimal. So to some degree, basically, this is going to be our binary representation of the phrase hello world, so that sequence of characters that we have. Okay. So there are a couple of other things that I can do with this file. For example, I can, when I run it, I might add some additional things, say like how's it going. So we'll go ahead and see that print out to the console. But then if I come over here and take a look at my binary file, you might notice, if you want to double check a little bit between the two different phrases, you'll notice that the data that's in here now is completely different from what was in there previously, because as I mentioned before, when we set up our output streams like this, it is going to overwrite the content that's in that file rather than append to it. So maybe if I wanted to, I want to go ahead and do some appending as well. We can go ahead and do that by modifying our file output stream. So in addition to specifying the name of the file, this is very similar to what we do with text files. We have an additional parameter that we can pass in. This is going to be a Boolean, either true or false. If we pass in true, this is going to tell it to append to the file rather than overwrite data in the file. So if I do that, let's go ahead and just remove what's currently in here. We'll save this, come back over here. So let's go ahead and compile it again, and then we'll run it. And now let's go ahead and put in both of those phrases. So we have hello world. So we've got that printing out. And then we'll go ahead and do this. And we'll also say, how's it going? Okay. And obviously, if I do this, it's only going to ever print out the very first thing that's in the file with my first portion right here. So it's always going to print out the very first thing that I'd put into it. But of course, now if we go and look at our file, we can see there's a fair bit more data than what was there before. This is because of the fact that it's combining both the phrase hello world and how's it going. Both of those are in this file stored together. So maybe one additional thing I want to go ahead and do is also set it up right here so that instead of only printing out the first string or the first UTF that it identifies, we can just go ahead and continuously look for things to print out. So if you want to do that, what we can go ahead and do is we'll set up a loop right here, but the way that we're going to approach this loop is going to be a little bit different from the way that we do it with text files. So whenever we're dealing with a text file, we had this hasNext method that we could use, but that's not really something that's available with the data input stream or file input stream with these particular methods. So instead what we need to be able to do is actually check for whenever we reach the end of the file, and we're going to do that through checking for certain exceptions that might occur. So the way I'm going to approach this, I'm going to come up here and I'm going to create a Boolean to check for the end of the file. And this will initially be set to false because when we first start opening this file to read from it, obviously we're not yet at the end of the file. So this should initially be set to false. And then right here, what we're going to go ahead and do is just create a while loop. So we'll just say while this is not true. So while end of file. So I'll say while we are not at the end of the file, then we want to go ahead and do this. And the way that we want to approach this is we're going to use a try catch right here. And for this particular part, we don't need to worry about using a try with resources since we don't have anything in the scope that we want to go about closing. We just want to continuously try to read from this file until we catch that end of file exception. So what we do, so we'll have our catch. We're going to be looking for the what is known as the EOF exception, so end of file. I'm going to go ahead and give it the name E. Again, that isn't really going to matter too much. And for this one, what we can go ahead and do is just change this end of file, this Boolean, to true. So in this case, what we're going to be doing is basically using this catch block as a way to tell us when we reach the end of the file. We're just going to change this to true. So when we go back to our while loop, after this catch block is finished, we move on to the next iteration of our while loop. At that point, end of file is going to be true. So this statement will become false. We'll stop running our while loop, and we've successfully read from the entire file. So we'll go ahead and save it like this. We'll come over here. I'll go ahead and clear what we currently have. Let's go ahead and recompile this. And then we'll go ahead and run it. And for this one, we'll go ahead and add a third line. So we've already got hello world and we've got how's it going. So maybe for this next one, we'll just go ahead and say I'm doing well. And now whenever we read from it, we're going to go ahead and read all of the content in it. So it's going to read the hello world, how's it going, and I'm doing well. So it's going to read off all of that content. And if we check in the binary file itself, we can see that yet more data has been added to it. So it's still continuously populating this file with more data, or essentially appending more data to the end of it. Okay. The last thing I want to go ahead and make a mention of, so this isn't really going to be something to try to practically demonstrate, although I might be able to make a slight edit to show it really quick. But one of the things to note is that this write UTF and read UTF, so you might be thinking in some cases, if you're just dealing with a sequence of characters, because that's essentially what a string amounts to, is just a set of characters. You might be thinking that you could use like a write UTF to go ahead and write data to the file, and you might be able to get away with doing something like read char to be able to read data from the file. So read char is going to be the method that allows you to read the individual characters, basically things of the char data type. And so you might think that this would be a useful equivalent to read UTF. So if you come over here and you compile this, you can compile it without any problems. So then if we go ahead and run it, let's say we want to add yet another phrase to this. So in addition to saying I'm doing well, we asked how's it going, we're going to say something like what are you doing today? So when this goes through, it's going to be able to write this to the file, but let's see what happens when it tries to read it from the file. Well, when it tries to read it from the file, it's going to read it off in essentially not as a sequence of characters in the way that we would expect. Instead, the way that it's interpreting each of these characters is completely different when it's a string versus an actual literal sequence of characters. So the way that it's interpreting each of the individual statements is going to be completely different. So in this particular case, what you're seeing is just like a sequence of what would this be, either Chinese or Japanese characters. In some cases, you'll also notice it does things like just random characters. In this particular case right here, this is actually when it doesn't even recognize what the character should be. So in some cases, you're just getting complete gibberish. So you can see that there's a completely distinct way that it interprets these different pieces of data. Say, for example, instead of doing it like this, maybe I do it as read int. Go ahead and clear all of this. We'll go ahead and compile it. And we'll run it one more time. And for this last one, since we asked, what are you doing for the day? Maybe we could say, I'm working on programs, since that seems to be all that we're going to be doing today. So we'll go ahead and do this, and then we'll print it out. And in this case now, it will still print it out as a bunch of integers, but again, this isn't really how it was intended to be read. So what we're seeing right now basically amounts to just completely random scrambled data. Okay. So it's very important to keep in mind that whenever you're trying to use a particular method, say like write UTF, to write to the file, you should always use the equivalent method, the equivalent read method, whenever you want to read that data from the file. So if we're going to write in the form of a UTF, we want to make sure that we read in that same format later. Okay. So this is going to wrap up this initial discussion about binary files, basically just going through some of the different methods, how we can go about using them, setting them up with try-catch blocks, as well as being able to talk a little bit about the relationship between the methods. Going into the next video, I want to expand a little bit more on binary files by talking more specifically about what are known as random access files. for being able to move to certain positions in the file and being able to read data from anywhere inside of it, as opposed to a text file, which is a bit more limited in its sequential approach to reading from a file.